Hello, everyone, and thank you for joining us. I'm Harry Urban, publisher of Woodworking Network, and I welcome you to our webinar, Advanced Nesting Techniques to Make You More Productive. Today's webinar is sponsored by SimTech. Our presenters today are Kenny Belfato, SimTech's National Sales Manager. Say hello, Kenny.
Hello.
And also presenting today is Giovanni Ramos, who is SimTech's Sales Engineer. So I'm going to turn it over to Kenny in just a second, but just a little more housekeeping. This will be a very interactive session. Kenny and Giovanni have 3 polling questions for you to answer, and we'd appreciate it if you would participate. Also, don't hesitate to ask your own questions, which you can do using the chat function on your control panel. Also, there is a download of this presentation available on your console, as well as a SimTech brochure. So please take the time to download those. And finally, this webinar will be archived and available within 24 hours, so you can view it again or share it with your colleagues. So with that, I'm going to turn it over to Kenny. Take it away, Kenny.
Hello, everybody. Thank you for joining today's webinar. Let's discuss the advanced nesting techniques to make you more productive. And with that, we're going to talk about SimTech. The company was founded in 1986, and we're really one of the first woodworking CAD/CAM softwares to embrace nesting technology. And this came about as high flow vacuum pumps became available in the 80s. Much more horsepower vacuum allowed the nesting to do what's called a flow through nesting, where you can just suck right through the spoil board to hold the sheet down. Back in 1986, we realized that your machine, very expensive machine in fact, is only as good as your ability to program it. So we integrated our computer-aided design and computer-aided manufacturing together, and that's what we call SIM, or computer integrated manufacturing. That's our first name. This is our web page, is sim-tech. We've got the dash in the name, and what it means is your CAD and CAM are combined in one location and one source. And with that, we also have full automated programming and this automatic nesting programs and advanced nesting features that we'll talk about today. Today's discussion is more about nesting and what is nesting and what is material optimization. And they're really, the word nesting and optimization go together. Today we're talking about router optimization or router nesting. There's also saw optimization as well, and we could talk about that in another webinar. But today it's going to be router optimization and moving and rotating parts on the machine and making your machine more productive. Also, how can you identify parts with labels? Because a lot of parts are going to look similar. It's a good idea to label those. And a lot of modern machines have automatic labeling as well, and we can program the labels for those machines as well. Then once all the parts are cut on the sheet, how to unload the parts effectively is just as important as how to cut them. So moving the parts off the table to their next location. We have a feature just for that. It's called cart control, and we'll show you how we can control the parts coming off the table. And then how to effectively handle all the advanced nesting techniques with the advanced nesting module that's built in to the advanced nesting. After this presentation, we'll have some questions and answers we can answer as well. So let's take a look. Here's the first survey question, if you can answer these.
All right, so for our first survey question, we have, do you currently use nesting software? Yes, no, or no, but would like to. We'll give everyone just a moment to put their answers in. All right, thanks everyone for submitting the answers. Glad to see that we have quite a bit of nesting users. It's for some of those people that said no, we'll pass it back to Kenny so we can discuss some of the details about nesting.
Okay, what is nesting? You know, there's a lot of descriptions for it, but really to produce as many parts as possible from as little material as possible. It's going to automatically move and rotate these parts around to fit on your sheet, give you the best yields. And it really comes down to the layout of the parts on the sheet. You could do this yourself. You have two choices. You could use commands like move, copy, and rotate and manually fit these parts together on your sheet. But the software can do that for you automatically, and it's always faster. All right, so in this case, this is a good example of a true shape nest compared to a rectangular shape nest. The true shape allows like this U-shaped part to have other parts fit inside of it, where if it were rectangular nesting, it would be as if there's a rectangle drawn around the part. It would only nest it as a rectangle. So there's a pretty good example right there of a true shape nest where parts are squeezed together on a sheet to optimize the yield on the material. And it's really about the material, because let's face it, no matter what the material is, if it's plywood or Corian, aluminum, UHMW, plexiglass, material is not free, it's very expensive, and you don't want to waste any of it. So we're going to maximize the yield on this. Here on this sheet here, you could see there's just a little bit of leftover on the top and on the side here, and that came from a 3D model to lay those parts out. There's even a feature that can choose the best sheet size based on yield or price. So if you had a machine that had a 12-foot table, you might be able to get your material in 4x8, 5x10, 5x12, and have the software figure out what's the best yield. It might be 2 sheets of 4x8 and 1 sheet of 5x10, where the best price might be 2 sheets of 5x12. It all depends on what your cost is. So the software can do analyses like that to figure out the best price or the best yield. Now, I had a wise man tell me once that they were never had a customer that was sorry they got a bigger table on their router or sorry that they got the bigger vacuum pump. It's just the opposite. They're sorry if they got a smaller table and a smaller pump because it limits you in the material sizes you can cut. You know, if you had the 12-foot table, you can cut Corian sheets that come in 12-foot. If you only had the 4x8 table, you're limited to just the 4x8 material. But no matter what, the nesting can optimize on any size materials you pick. You get to choose the spacing and the rotation of the parts, whether they're grain rotation and so forth. These are all settings for the material optimization. Here's some other examples of optimization, and here is a rectangular nest. And these are really best suited for like a common line cut, where one tool can go in between the parts and cut 2 parts at the same time. That could save an enormous amount of cycle time compared to cutting all the way around each rectangle. We could do a common line operation, and it just goes between the 2 parts, cuts 2 edges at the same time. So it's up to 40% less cycle time compared to going all the way around each rectangle. And then this here is a true shape type nest. And this is just a fun part here where, again, it's got the true shape, so parts fit together nicely on here. Okay, again, you could choose the spacing and get parts very close together. You can also do other things with the optimization. If you don't like how the nest is laid out, you can use editing commands like move, copy, rotate, and change the nest yourself as well. So it's all about using as much of that material as possible. We can even do filler parts. So this little part here, I could say I need 10 of these, but give me 20 filler parts, and it would fill in these areas. There's extra material, and you could do that with things like rosettes or any kind of small piece that you can make extras of are ideal for filler parts to really fill the nest in so you don't have any scrap left over. So let's talk about the productivity, because in reality, you could break down how much your machine costs into an hourly rate. If you're paying a lease on a machine, it has an hourly rate. The machine costs so much per hour to just sit there on the shop floor. The more parts it makes and the more the machine runs, the more money that the machine is earning you. And the machine cycle time is money. So not all nests are created equal. This nest is got a, we call this just a regular type of nest where the tool will cut one shape, then wrap it over to the next shape, and then rapid and rapid and rapid. So if you watch your machine cut today, it'll lift up and move from part to part. And at the end of the day, if you could capture all that rapid motion, it might be enough time to run 3, 4, 5 more sheets of material. So you can get faster cycle times and increase productivity using things like one of the advanced nesting features called stay down cutting, where the tool will stay down and connect from one part to the other without lifting up. And that cuts up to 20% on the cycle time. Today's version of stay down, SimTech is a version 3 on the stay down nesting. The first version had the tool path start and stop in the same spot, and sometimes that would leave a little bump and the machine abruptly would stop and turn direction and go to the next part. The next version 2 had an overlap built in, so the tool would go past where it started and it would eliminate the overlap or eliminate the bump on the part. And today's version 3 has a tangent arc in and a tangent arc out, which means the machine can move much faster from one part to the other. It's very fluent without any risk of a bump on the part. And again, an increase in improvement in cycle time because the machine is moving with tangencies from one part to the next. Makes a big difference compared to just lifting up and moving over from one piece to the next. Here's another survey question for you, please.
All right, so the next survey question coming up. Is labeling important to you? No or yes? We'll give everyone just a moment to put their answers in. And it looks like labeling is fairly important to everyone. We still had a few holdouts and we'll pass it back to Kenny so we can go over the importance of labeling.
So let's face it, if your machine can cut hundreds of parts in an hour. If you're making those MDF doors, for example, or cabinet parts, for example, a lot of those look very similar. The doors could be, just maybe 1/8 of an inch apart in size in X or Y direction. So it's important to be able to identify the parts on the sheet and stick a label on there. So with the RouterSim program, it automatically prints all the labels for all the parts. And you can customize the labels to put whatever information you like on there. A picture of the part, a barcode, the material, any kind of label properties you want. You put many label fields on your parts. And you can set the size of the label and so forth. Some of the modern machines have automatic labeling. So this little picture here shows basically it's a suction cup that goes over and grabs a label out of the printer, and it knows where to stick the label on the sheet that has not been cut yet, right? You want to put the labels on first, then do the tool paths so the sheet is clean. There's no sawdust, the labels will stick better, right? And we do both. We can either manually put the labels, an operator can manually place the labels, the RouterSim will print all of them, or we can direct the machine to print labels and stick them in place where they're supposed to be. So this is a very popular option on a lot of machines, is automatic labeling. This is a preload table and sticks the labels on there, then puts this sheet onto the router, cuts out the parts, and then it unloads them afterwards as well. So the labeling is so important. We offer another feature called Touch and Print. And this shows a picture of the nest that's laying on the table, and the operator can touch a part and print a label right away. So this is interactive labeling. Without this, the operator can look at a printout of the nest, and find a label 2 and stick it on here. Find label 40 and stick it on this one. You know, he can look at the numbers and put the labels on the parts manually. But with touch and print, he can graphically see them. And this will run on a computer. It can run on the router itself if it's a PC-based router, or a little computer by the router. It's a low power computer that can run this. It has a printer plugged in, whether it's a shop hardened printer like a Zebra or just a little Dymo printer. You can pick whatever printer you want, and this will pick and print a label. So this is a great way to do it. Then you could scroll through here and pick whatever the next sheet is, and it'll show the picture of the next sheet. This is a great option to consider, called Touch and Print for interactive labeling. Now let's talk about effectively unloading the parts and moving the parts, because let's face it, in 4 or 5 minutes, the router can make 30 or 40 parts. It can cut a whole sheet in just a few minutes, and then you have a pretty big stack of parts to deal with. So this is a good picture because it shows several routers together, and it shows here pallets that they're putting the parts onto pallets. Some people put them on a pallet. Some people have carts that they put the parts on, or a conveyor system to put the parts on. There's a feature called cart control that lets you effectively unload the parts, because if you mixed 10 products together, you could get a really good yield because you have all these different parts to choose from. But on any one nested sheet, you might have parts from all 10 products or all 10 jobs. And there's probably not enough room by the router to put 10 pallets or 10 carts. In this case, you see there's only it looks like there's 6 pallets by this router. So you can limit and say, let's offer, hey, I only have enough room for 2 carts or 2 pallets, and then it will only put 2 jobs at a time on the sheet. And that way, when you unload them, you only need 2 carts there. Now, that also affects your yield. If you're only going to go down to 2, your yield might fall. And so there's a protector that you could put in a percentage, let's say 80%. If the yield falls below 80%, then go ahead and add another job or another product till my yield gets back to 80%. So this is great for unloading, and you can see the mess that piles up pretty quickly once you're cutting, several routers, cutting many nested sheets. This is another example of cart control, and here are those settings for the multiple stock size. For example, there's 3 different material sizes here, and they can have a priority, they have a quantity. You can have it automatically decrease the quantity as well. And you can put in costs for each sheet, and that allows you to nest by yield or by price. Here's the clamp right here. So if it falls below 95%, sorry about that. If the threshold falls below 95%, go ahead and add more pieces till it gets to 95. This is also an example of a zone nesting. So this router had 4 zones, and you could see this little plus sign here, and it's keeping the parts inside the zones. So you could do that as well. We have many different types of nests. There's even one called irregular stock nesting. So you could draw a circle and have parts nest inside of a circle or an odd shape. That also allows you to draw, a 4x8 sheet and mark off where you have knots or imperfections in the wood and keep your parts away from those imperfections. So the nesting can avoid areas on a sheet. In this case, it's nesting in zones, and it's doing the cart control type of nesting. And it can also do a multiple stock size nest by yield or by price. There's also skeleton cutting too, which we'll talk about in a little bit, that chops up the remnants for you. Here's a question number 3 for the surveys.
All right, so the next question, how many nested sheets do you cut per day? Less than 5 nests, 5 to 20, over 20 nests, or not applicable? We'll give everyone just a moment.
Excuse me.
All right, and the results are in. Looks like the majority is producing over 20 nests. and we will pass it back to Kenny to talk about some of the productivity boosting strategies to increase that.
Okay, so here are a list of the items that are in the advanced nesting module. And these are all designed to boost your productivity as well as reduce the cycle time, which is also a boost in productivity. There's stay down nesting that connects from part to part without lifting up. The common line cuts between two parts at one time. There's two-sided nesting. So if your parts have machining on both sides, you can put the sheet on the table upside down and do all the backside operations on any of the parts in the nest that needed a backside. Then flip the sheet over and do the front side. There's there's cart control, which we talked about, which is for unloading, and then multiple stock control, so you can nest by yield or price. We have a feature called veneer match, which allows you to keep your drawer fronts or door fronts together in a nest, so that when they're assembled in the product, all these drawers, for example, would stay together in the nested sheet. And then there's also a very important feature for nesting is small part control. And with the router sim, you have 3 levels of parts. You have large parts, you have small parts, and you have extra small parts. And you can apply a strategy to each one of those pieces and their size. That way, your small parts could have an onion skin, for example, and the extra smalls could use tabbing. Or at the very least, the small and extra small get cut first while you have the most vacuum. Also, keep the small parts towards the center of the sheet, because on the edges, there's not as much vacuum because there's usually a lip that holds the spoil board up there. So we'll talk about small part control. And then there's also a skeleton scrap. So along the top edge here, if there's anything left over, the router can chop those remnants up. Instead of your operator picking it up and using a saw or whacking the remnant on the dumpster to break it up, you can have the router do that, and it's safer and can save you time compared to somebody else breaking up those pieces. Here's the first one, is stay down cutting. And like I said earlier, we're at version 3. So you'll see as this is cutting these parts, it connects from one part to the other without lifting up. And you can expect to save up to 20% on the cycle time by using a stay down type of nest. If you cut a lot of melamine, maybe you get a chip on the part where the tool enters and exits. We can apply a lead angle so that we're still ramping in, but we're ramping off the edge of the part. So if there is a chip, it happens on the scrap and not on the actual part. This stay down nesting has an overlap and a tangent arc in and out to the next part. So it's going to run at full speed and connect from one part to the other without abruptly stopping and changing direction. This version 3 of the stay down means that the stay down nest is even faster than the previous versions 1 and 2. That's in our 2023 version of the RouterSim software. So you can get an idea how the tool just stayed down and connected part to part. This also works with small parts where I could, for example, cut almost through the small parts in this nest. And then the stay down goes ahead and cuts all the parts free, right? So the almost through, the little guys are still being held with just an onion skin. And then as the stay down pass comes along, it goes and cuts everything free at the same time. So there is a way to use stay down and small part control at the same time. Here's the next big one for productivity. It's called common line. So if you can imagine a zigzag left and right and a zigzag up and down, that will cut all your squares and rectangles. And that's really what the common line is used for. It's common lines for squares and rectangles. If you had a bunch of circular shapes, there's not really many common edges there, right? So common line connects, it spaces the part by exactly the tool diameter, and one tool path cuts 2 parts at the same time. With that, you can expect to save up to 40% on cycle time compared to cutting all the way around each rectangle every time. So common line can save you a lot of time But it's really all about squares and rectangles. And then it's also has to be, your material has to be tolerant of both climb and conventional cut, because as a tool is going between two parts, one part gets climb cut, the other gets conventional cut. So things like MDF and plywood should be no problem with that at all. That's common line nesting, a huge time saver on rectangles and squares. Here's two-sided nesting. So traditional method, if you had parts that had machining on both sides, would be to nest the parts and then one at a time flip the parts over and cut the back side of them. We have an automatic two-sided nesting program. So there's other two-sided nestings out there. Ours is completely automated. You can tell the software what layers are on the back and what layers are on the front. And you put the sheet on the table upside down. In this case, they're doing pocketing and cup holes on the back. Then it will trim the edge of the sheet. So when you flip it over, it's a nice registered edge that goes back up against your fence or your pop-up pins. And then it does the front side. So the parts come off the table, machined both front and back, all automated. It's going to make two separate programs for you. It could also, on request, make one program with a pause, but we prefer to make it as two separate programs so you have a full cycle stop in between there, and you flip the sheet over. We've done automation for some customers where they have a robot that flips the sheet over for you automatically. So this can be fully automated. Even the flipping process can be automated. Now with this two-sided nesting, you can even cut halfway through on the back and halfway through on the front. So you can imagine if you want to put a round over on the top and the bottom of your parts, cutting halfway through on the back and halfway through on the front would do that for you. Compared to the traditional method, you'd have to elevate the parts off the table and use a bullnose cutter, and it would allow you to put the radius on the top and the bottom. The other advantage, cutting halfway through in the back and halfway through in the front, is that you're not etching into the spoil board and you won't have to resurface the spoil board as often, right? If you're cutting halfway through, you're never etching into the spoil board. So keep that in mind. If you ever have parts that have two-sided, parts that have machining on both sides, or an edge treatment on the top and the bottom, this two-sided nesting needs fully automated, might be a good productivity booster for you. Here's the cart control, again explained, but with a colors and graphical explanation here. It's a balance between the yield and the workflow to meet your requirements. You know, how much room do you have around the router to put parts on the carts or pallets? If you got enough room to put 10 pallets around the router, then you can mix up to 10 different jobs together. In this case, they only have 2, so there's never more than 2 colors on the sheets at once. And never more than 2 colors on there. And the color represents the cart. The cart can be based on a label field. So everything that has a label that says kitchen is one cart. Everything that has a label that says bathroom is another cart. Everything that says bedroom is another cart. So you want, you know, if you had 3 carts on the table at once, you get parts for all 3 of those rooms on the sheet at once. And then you need 3 carts or pallets to unload the parts onto. If you can only fit 2, then you could tell it 2, and then you could put a protector in for your yield, so that if the yield falls below a certain amount, you would have that automatically add additional pieces for you. That's cart control for offloading. Here you could see these sheets are all different sizes. This is the multiple stock control, and you can set this for best yield or best price or by priority. And it'll also can decrease the quantities for you automatically as well. So you can tell it you have 10 sheets of 4x8, 5 sheets of 5x12, 4 sheets of 5x10, and it will mix the yield. It'll mix the nested on the different sheets. And you see all of these sheets have a fairly high yield. There's very little scrap left over on any of these sheets. If I were, for example, to just use 4x8s, I might wind up with a half a sheet left over on the 4x8. So by doing this, again, if you have a large table router, you can get your material in different sizes, and you might be able to get one size cheaper, depending on your supplier. He might have a deal on a certain size material, and you could plug that price in and it'll nest by yield or by price. Also, there's some remnant across the top here and on the side, and there's, you can see those little skeleton cuts. So the skeleton cuts are chopping up the remnant that's left over. Instead of this long L shape, the operator would take that and whack it against the dumpster, right? We'll use the router to cut those up in little 24-inch segments. You set the spacing and the parameter, and it'll chop those up for you. Here's the veneer match. It's also called grain matching. And you can see this beautiful product here has the grain goes right across all of these, right? So that is grain matching. You want to keep these drawer fronts together in a nest. And here they are right here. They stay together, and you can make as many grain match groups as you like, and they will stick together in the nest so that you can have your grain look great on the product. Grain matching is the easy setting in the RouterSim, automation program. Okay, so here we could talk more about the small parts. When you're nesting, the flow through type nesting means the parts are really just sucked through the table. It's sucking right through the MDF spoil board. So your small parts need to be cut first, and they need to stay away from the edges where there's less vacuum, right? You have less vacuum on the edges because there's a lip to hold the spoil board in place. So there's a setting to keep the parts away from the edges. There's a small part nesting zone here. The big parts can go right up to the edge. So you see some of these big parts, the ones in red are the small, and the green are the larger parts. You can also set a bigger spacing. So your small parts can have the larger spacing so that they could be held with tabs, for example, right? If these parts are right next to each other and there's tabs, one part's going to cut the other part's tabs off. So you can set a larger spacing. You can keep small parts away from the edge. Like I said earlier, there's 3 different levels. There's large, small, and extra small. And you can have different strategies for the small parts. Onion skinning, reverse onion skin is another technique. For example, you cut all of the small parts almost through on the sheet. Then one at a time, you cut the small parts all the way through. Then you go back and cut the big parts. So that way you had the most vacuum, okay? So the onion skin left on the small parts means that when they do get cut all the way through, they're less likely to move. We got a lot of different strategies for cutting the small parts and keeping them away from the edge and increasing their spacing so that they can have tabs on there. Here's more on the skeletons again. So you have a remnant here, like an L shape, and these little lines are the tool path to chop up that remnant. And I know everybody knows that you take that and you've seen the operators whacking those pieces against the dumpster to break them off. Well, what happens if it ricochets and hits somebody in the head, right? You can chop the router can chop those up. It's safer, it's better, it's faster, right? So you can use this feature to do skeleton cutting, and it'll use your router to chop those pieces up. Here you can also see the little stay down connector from one part to the other. There's just a little tiny little connector here. If I zoom in on that, there's an arc in and an arc out.
All right.
So,
Thank you,
thank you,
Kenny.
Giovanni.
No problem. Thank you for going over those advanced nesting techniques that we at SimTech offer to help our users become even more productive. Also, for us at SimTech, we understand that squeezing every penny out of our CNC machines is as important as ever during these times. So our aim is to help you automate and elevate your machine's capabilities to be as efficient as possible. Software tools such as our advanced nesting capabilities help to do just that by giving you better yields and more efficient cutting strategies, and even various methods to keep better track of parts as they come off of your machine. We want to thank you all for taking a closer look at our solutions today. And with that, let's now open up the meeting for our Q&A session. So if anyone has any questions that they'd like to ask Kenny about what we've discussed so far today, please submit any questions that you have now. All right, and it looks like we have some coming in, and Kenny, looks like we actually did have a few that already came in, so let's go over some of those. First one we saw was, does stay down and common line work with cutter comp?
Okay, yeah, that's a great question. Stay down does. With the stay down type of tool path, you can use full cutter compensation, because as your tool wears and it'll get smaller, then your parts will get bigger, right? So you can use cutter compensation on most controls, and we can adjust for the tool wear. Now, remember that little overlap that I talked about and the arc in and arc out? Those need to be at least the size of your cutter comp so that you don't get any cutter comp errors. But if we program the tool center and just use small values for cutter comp, then you can have very small arc in and arc out and very small overlap. So the stay down nesting is fully compatible with cutter compensation. The common line, however, is not. Common line cutting requires you to put in the full tool diameter into the software, and then the parts are spaced by that tool diameter. And one tool path goes between the two parts and cuts two parts at the same time. So common line is again for rectangles and squares. Its advantages, it's 40% less machining, but its disadvantages, you can't use cutter compensation, and some parts get climb cut, some get conventional cut. If you can overcome those with your material, you could save an enormous amount of time cutting rectangles and squares. Stay down works with any shapes, squares, circles, odd shapes, and does use cutter comp. So if you need a requirement for cutter comp, then I would say go with the stay down type nesting. If you just want to cut a lot of parts and the size and the accuracy of the size of the part is not that critical, as well as the finish on the part is not critical, then common line can really save you more time.
Okay, great. Thanks for breaking the differences down. Hopefully that makes sense for whoever asked that question. We had another one that came in. Does RouterSim report the nesting yield and cycle times for the nests?
Yes, the answer is yes to that. You can have reporting saved as PDF files or Excel spreadsheets, and it's saved in a pivot table too. So if you're an Excel expert, you can really compile that data and use it in an ongoing report as well. So we give you a cycle time based on what's called a kinematic time study. It takes into account the machine's acceleration, deceleration. So it means if you cut a part that's 1,000 inches in size and you had 1,000 inches per minute, it's really going to take 1 minute, because the laws of physics say the machine isn't instantly going 1,000 inches a minute. It has to slow down in the corners too, right? So we have the very accurate cycle time analysis. And then there's a yield as well for each sheet in the nest. It'll produce you a yield and tell you what the yield was and what your scrap area was. And it can even break that down. If you had the price in on your material, it could tell you how much it cost in scrap, and really give you a lot of detailed information about single parts and nested sheets. So you do get full reporting for both of those, cycle times and yields.
Great. Yeah, it definitely sounds like a lot of useful information about whatever job that they're running. We also had another one come in, Kenny. Can you nest 2D drawings and 3D solids in the same nest?
Oh, that's a good question. Absolutely. You can mix and match any kind of data in the nested drawing. So RouterSim can cut 2D parts, it can cut 3D parts, and it can also cut parametric macros. Things like those MDF doors, for example, are macros where the user just plugs in dimensions and it draws the door and then nests it. So you could just plug in a dimension, ask for this kind of door, this big, and it'll go ahead and draw it and nest it, tell how many you want. If you're drawing in 3D solids, take a look at our SolidSim software, and I believe we've done a webinar in the past about SolidSim. It's automatic feature recognition that could take like Inventor or SolidWorks or any kind of 3D modeling assemblies and break those down into parts that can RouterSim can nest quickly. So we can mix and match any of those, as well as if you don't like the nest results, you can change it. You can use move and copy and rotate and change the nest results any way you want to.
Great. So it definitely sounds like it's a little more flexible than maybe as originally thought. So that's good to hear. We had another one come in. Is there a subscription for nesting?
You could buy our nesting in two different ways. You could buy it as a own it version, and you own it and you have unlimited nesting capabilities with that. And it's a great addition to anybody that wants to do automatic nesting. You can just get the RouterSim nesting software to own, or we offer what's called cloud-based nesting. And it's like a subscription. You can get it on a monthly basis or renew it every year, every 6 months, and you get unlimited nests based on a time frame. So it's nice if you just wanted to try nesting out, you could just get a month or two of the cloud nesting and see what it does for you. It keeps track of all your nests, and you can run those through your existing RouterSim program. It's just an activation code to get that started. So if you want to try it, there's a very easy way to get the subscription-based or cloud nesting.
Awesome. So there's quite a few options available for that. We had one come in that was also a pretty good one here. Says, earlier in the webinar, you mentioned that nesting via software is, quote, always better. What if I'm somehow faster by hand? What other advantages are there to having the software doing the nesting for me, if any?
Well, I said it was faster. It may not be better, but it's faster, okay? So at the expense of time, you could spend a day moving and rotating parts, and you might be able to get a better yield doing it yourself. I'm going to be perfectly honest with you. If you spend a lot of time on it, you might get a better nesting yield. But the software is going to do it for you much, much faster. All right. And then as far as the other advantages, what about stay down and command line? Okay. So it would be very time consuming for you to try and draw and lay parts out and lay a command line toolpath between those. It would be very time consuming for you to try and draw a bunch of parts and then connect them together and do that. So it would be very time consuming for you to try and figure out the yield based on price or, nest by yield or by price. So all of these things that we saw, the cart control, the stay down, the command line, skeleton cutting, multiple stock size, those are all the reasons why the nesting is better. Those are all the reasons.
Okay, so it's more so of a more flexible approach, and you get a lot more different options that you want to let the machines handle, right?
Yeah.
So we had one more as well. I think we only have time for about one or two more. This one says, can a skeleton cut go beyond the stock edge as to help chop up slightly oversized material? So what are your thoughts on that one?
Yes. There's settings for the skeleton cut. And you can add lead ins and lead outs, or just a lead out, or just a lead in. I will go past the edge of the piece. You can also keep it inside of the piece so that when you go to pick up the remnant, it's just held together with a little tiny little piece. So you can still pick it up as one piece. And then as you just move it, it's going to break apart, right? So let's say you stayed away by a 1/16 of an inch from the edge. This real long strip is going to be held together, but it's very easy for you to break it apart. It can cut it all the way off, and then you just have a bunch of little sticks. It can go past the edge of the sheet, or you can have it stay within the sheet by a small amount, so it's easier to move and handle that remnant.
Gotcha. Okay, that makes sense. And I think that is just about all of our time that we have for our Q&A section. If we did not get to your question so far, we'll reach out after the webinar. And Kenny, go ahead and take it away for last little bit of information here for them.
Thank you so much for attending the webinar. Here's our webpage is sim-tech. Feel free to call or email me if you have any questions, want to see your own parts nested. I would be glad to lay out a nest for you. If you're using existing nesting software, compare yields, okay? Even just a small difference in yields can pay for the software over a time. So we would be glad to compare those with you. We usually get a better yield than a lot of other competitive software. So I'd be glad to do that for you. Contact me with any other questions, and thank you so much for taking a look at the advanced nesting features in RouterSim.
Well, thanks, Kenny, and thank you, Giovanni. On behalf of Woodworking Network, also thank you to Simtech and our audience for great engagement today and participating in our survey questionings. You guys did a great job of shedding light onto this critical manufacturing topic. So once again, thank you all for joining us. And with that, I'll say so long, everybody.
Thanks.